We're waiting for the stream to start. I have no idea if this is going to work. Do we have audio coming through? Do we have audio coming through? Yes, we have audio coming through. Good. So, I got a new internet connection. We're streaming at twice the bitrate we have in the past. And that is cause to celebrate. So, the subject on the bench today is an old CS750M power supply. I have no idea of its history. It sat in a what was it? Water-cooled Haswell based PC. Saw quite a bit of sitting around. I don't think it got too many hours on it, but it is the cheap model Corsair power supply, semi-modular, but it's not the most expensive model. Rated 750 watts, of course. What do we have? 62 amps on the 12 volt rail, so a rather beast of a power supply, really. Worth checking out. Could be useful in some random PC. Better than throwing it away. People are showing up in the chat, saying hello. Hello everyone, glad to see you around. To those just checking in, we're streaming on our new fibre internet connection, so everything should be as high fidelity as the streaming PC and this piece of crap camera can handle. So this power supply has never been taken apart before. Warrant avoid sticker. Oh, that's a satisfying feel. Let's see what we have inside. So right through the grill I can spot some solid caps as well as some TPO caps. So we've got a mishmash of quality components. They do seem to be black TPOs, which are generally better caps than the green TPO SC series capacity you often see in really trashy power supplies from about 10 years ago. So they should now rip apart with relative ease. Chat says, hello from Romania. Hello Romania. Giorno says brand new unit. No, this is not a brand new unit. The Tute Face says, is that one of the units with a crazy long warranty? No, this is not one of those. This is the CS series. They are pretty cheap. Not the fanciest power supplies at all. So, finish on the connector. So, there we go. Off it comes. The fan is Yateloon DS D12 SM sleeve bearing, 300 milliamps. A chuffer. This is going to be loud and break in short order. Sleeve bearing, of course, pretty trashy. Also has one of these ridiculous air guides which just block half the fan. Pretty useless. So this is the actual unit again. I don't know how many hours this thing's got. I don't think it's too many. So we do have a bunch of TPO caps. TPO, are all of them TPO electrolytics? No, not all of them. We've got some Elite branded electrolytics there on the probably 5 volt rail, 10 volt rated. None of them have gone obviously bad though. Although we do have a bad one on the primary side. You can see it in the lower left corner of the screen there. This guy has an obvious bulge to it, so it's probably due for replacement. So that's probably going to be the bootstrap capacitor for starting the unit when you first power it up. So when you plug it into the mains before it's gotten the oscillator running and switching to the secondary side to power itself, this is the cap that's going to supply the switch mode controller. Very common failure mode, and when these go bad you usually have a PSU which works fine until you have a power outage or you plug it out, or you unplug it, at which point it will just promptly never power on again. So the This is not an 80 plus rated unit, it's probably going to be reasonably close to 80 plus anyway, even though it kind of predates the popular ratings. And so I think it might be worth replacing that one cap, even though it's going to be a bit of a bother taking out. Rubicon branded primary side, look at that! The 400 volt 330 microfarads, quality caps, that is rare. Those caps are usually garbage brands because it's a very expensive part. They cost several dollars each if you buy one, and probably several cents each when you buy 10,000. So let's just start taking this thing to all its bits. I do think we need to... we may be able to get away without removing the modular plugs around the back, but we do need to get rid of this thing. James7466 in the chat says it's 80 plus gold. It's not. I googled it as well. Corsair reuse their model numbers, so this is not the 80 plus gold model. It's some much older unit. I can spot a date code as well. We've got 1432 there, so it's probably purchased early 2015 or so. Super Boobaloo says, I think you worry too much about your streaming setup. It's usually more than good enough. It has been. The streaming setup has been good enough for you guys. However, the amount of work required to set up each stream has been ridiculous because I've been using two internet connections. One basically solely for streaming and uploading to YouTube, and one ADSL for things which require more stability. So in the past, the streaming PC, this guy you're watching on, has been going through a 4G connection on the attic, and this PC has been going through ADSL just because just using one of those connections would just saturate out at any kind of streaming quality. I wouldn't be able to monitor what I'm doing on one connection. But now we're using 100 megabit symmetrical fiber, so that's a non-issue, and I am very, very happy about that. The ADSL would also cut out all the time because there's a lot of electric fences around here since I live on the countryside. So if I were to try and stream on my ADSL, it would basically cut out several times during a single stream. The 4G would also sometimes kind of do that, and performance on the 4G was anywhere between 1 and 20 megabits upload. So it was I had to run a speed test and readjust the stream settings every time I did a stream, and bloody well hope that the tower doesn't get loaded down while I'm streaming. So yeah. My internet has been really, really bad, but we're finally free of that. Someone doing what I do really... You really learn to appreciate decent internet. You really learn to appreciate it because you're so dependent on it. Symmetrical FF symmetrical it says symmetrical. Okie dokes. Oh, iFrit05 donated $5. Thank you very much. That'll go straight to paying the €995 bill for connecting the fibre. That's a bit of a hit, but it's worth it. It's worth it. I'm willing to pay €995 for you guys. That's okay. We do need to take these out and destroy the unit because the PCB is kind of lodged down underneath the connection board. Super Boobaloo asks, how much poorer are you for that kind of bandwidth? Well, as I said a moment ago, the fee for connecting the fiber to the house was €995, but the monthly fee for 100 megabits symmetrical is just €40 a month, which is less than what I've been paying for the ADSL plus 4G I've been using. So I've obviously cancelled the ADSL and I'm going to cancel the 4G. So say for the €1,000 connection fee to get it connected, it's really just as expensive. It's not going to cost me more in a month, and that's just because it's so much cheaper for the telecom to be running fibers, since they don't have to deal with the extra copper infrastructure which we're trying to get rid of. So that's very good. ADSL is just a very expensive technology, since it's just riding right at the limit of what the telephone cables can do. It's so finicky. Like they've had to replace the telephone line to this house once already, which is as much work as it is for them to just pull a fibre in here, and they do that for free because they have to provide service. S. Corgina asks, hey, is this only a teardown or repair too? We're going to repair it. In case you're just joining us, this is a Corsair CS750M power supply, which is not had with Star Test 80 plus anything anywhere, so I don't think it is. And we have spotted an obviously failed cap right in there. This guy is bulging, so that's going to be the bootstrap capacitor for the primary side switching IC. That's gone bad, and we're going to replace that. And I forgot to turn on the desoldering pump, so it's going to take a while before we're actually heated up, which is annoying because that thing takes forever to turn on. But in the meantime we can have a closer look at the unit. So all the semiconductors are probably going to be good in this. I think I actually plugged this thing in and it did work for a test once, so I'm pretty sure there are no major faults in it. Now the PC it was in was discarded because it had water damage on the motherboard, so probably not any damage on this thing. That chip over there, I don't know what that is, don't quite care. But the electrolytics on the secondary side, this is actually a 1000 microfarad 25 volt rated TPO SY series. Yeah, the TPO SY series is a-okay. These are decent caps. Generally, black TPOs are rated quite well. I've seen them run many an hour without failure, as long as they don't run too hot. So this cap I actually have confidence in. I like that they've rated it 25 volts despite not really having any need for that. It's going to be on a 12 volt rail, most likely. But this guy's a Capxon, something or the other. Capxon 680 16 volts. Now I'm not entirely sure about blue TPOs. They are SZ series. I'm going to actually look up TPO SZ series because I'm not entirely sure. Generally, the brighter the color of the Chinese cap, the worse it is. TPO SC PDF. What do we have? No, not SC, SZ. Let's see. PDF download from tpo.com. 1000 to 2000 hour rated. So they are lower impedance versions of the SC series, and SC series are the green TPOs you see failed everywhere, so I have very limited faith in these. They should probably be replaced if I have any suitable replacements. But then again, the question is this power supply really worth putting all new caps in? And what are they rated? They are rated 2200 microfarad 16 volts. Ugh, these are relatively expensive parts. Do I have any 2200 16 that's going to fit there? I'm not sure. Oh, I do. Oh no, I don't. I have a 2200 6.3 volt Panasonic FRs, but I don't think I have any 16 volt ones. So I think we're gonna have to live with our TPO SZ series unless I have something hidden away. 1035. That's not going to cut it. This is looking dire. I don't think I have suitable replacements. Nope. But I'm quite confident that these caps aren't bad yet, because TPOs generally bulge when they go bad, because they die under heavy load, under high ripple current. So I think this thing is going to be fine, but I'm going to get rid of this Elite because that's a 680 microfarad 16 volt cap, easy to replace. So let's find a 680 microfarad 16 volts in my off-camera component drawer, and let's get soldering. So these are 680 microfarad 16 volt Chemicon KZEs, which are perfectly fine caps. So I'm not going to build this power supply for super reliability. I'm going to build it so that it'll kind of run well enough to work in a decent, normal, like gaming PC, something like that. Alphonse Jean says, "Hello, finally alive, I don't miss." Hello indeed. Economical, dubious repair again? Kind of. This thing isn't really broken, we're just replacing a couple of caps, and it should be in decent enough condition. I'm just going to fix it, till it runs well enough for me. Don't think I'm going to sell it. But anyway, this main felt cap is rated 100 microfarads 50 volts. Dear, I'm not sure I have a suitable replacement for that. That would be annoying. Let's see, 100 microfarads 50 volts. I have something. Is that 35? Oh no. We have one singular 150. And I'm also spotting a tiny cap in there by the failed one. We're going to get rid of that as well. That's 10 microfarads 50 volts. So DV those three caps, and I think we're going to be good enough. 10 microfarads 50 volts. Should have those. 1063 coming right up. There we go. Put this in, and I think we're going to have a happy power supply on our hands. I want to adjust this thing ever so slightly, that way. Put some water on the soldering iron. I really need to order some new tips. Because these are starting to fall apart. I'm basically just waiting for the heater in my current soldering iron tip to just not work anymore. At which point I will scramble to order a new one, rather than doing it before I have to. What's the chat saying? Are the large wires going to be modular board silicone? Nope. Google for CS750M Johnny Guru for an in-depth test of the 850 watt model, 80% to 91% efficiency. I don't think this is the same series. I think this is an older model. I don't think this is going to be anywhere near 80 plus rated. Right, maybe with these solderings hot by now. Sounds like it, so let's get soldering. Let's start with the secondary side Elite, the 680 microfarad 16 volts. That's gonna be really difficult to localize, aren't they? Those pins right there, those two. I think I need to add some heat and solder with the normal soldering iron before I get the pump in there, because the pump doesn't have the thermal capacity to heat this very heavy track very well. That's one pin. Now we'll pump some heat into the other one as well. Since we're sitting just by this big high current slab here, we're heating all of this, and we're heating the wire going out there. So the desoldering pump really isn't going to have much to say about that, but the 72 watt OE 2901 has plenty of grunt for it, and since we're preheated, we're going to slip that right up. And fall right out, and I hope there's a polarity marking on the board. There's a polarity marking on the board, I didn't see that, good. Although it is obvious from the way the legs are bent that it was going to go negative side that way. So that's a 680/16, here's our new one. In you go. Same size and all. And we will just make some smoke. Plenty of heat, because it's so much copper there. I'll just make a big blob of these 3 pads there. About the same thing. Okay. These are the same thing, right? I didn't just short everything out. Better to be safe than sorry. Yeah, I'm not sure actually if... I'm going to suck that solder off actually, because I'm not sure what I did is going to work. I'm skeptical that these are actually the same pattern. It would be rather unnecessary to just bridge a bunch of pads together without good reason for doing so. Yeah, a couple of them are the same, but I'm not sure about the third one. There we go. First cap in place. Right, let's move on to the actual issues, which are going to be these two guys down there. So they're right by the big TO247 package. Negative side on the big one is pointing towards the TO247. So we've got the 247 there, and the caps are going to be probably, well, that's probably one of them. Let's zoom in slightly so that you might have a shot. This is the big TO247, and where are we? I think that's going to be our capacitor, because the lead spacing is roughly right, and the cap legs usually have a little bend on them since they've been poked through at an angle. So I'm just going to try and stay in shot. Oh god, I'm putting PSU wires all over the keyboard and it's doing things in OBS. I'm hoping I didn't just destroy everything. Right. This one I think we can just suck clean off. Yeah, don't even need flux. Let's see if I was correct in my components. Ta-da! There is our swollen Capxon 100 microfarad 50 volt cap. So let's verify that this is bad. Sometimes caps can just look kind of swollen because they're manufactured that way. So I'm just gonna bring up the ESR meter on my little laptop there. You can enjoy my beautiful wallpaper while I go looking for the ESR meter, which is right there, and the USB cord, which is terminating right there. Plug that in, and we try to plug that in. There we go. Now we try and find the leads. And there are the leads. So bring up the application, and again, I'm sorry if you're curious about getting one of these ESR meters, I can't help you. I'm not allowed to share it. I'm not allowed to share it. So we'll zero out our leads. That's 120 milliohms gone. Put in ESR mode and measure our capacitor. So that's actually measuring fine. 100 microfarads, 125 milliohms. So, despite its horrible looks, this capacitor is fine. It could have just been running extremely hot, I guess, and started to ever so slightly heat up and expand. Like, the thing about the bulging caps, which not everybody knows about, is the bulge comes after the failure. Because when the capacitor gets old, the internal impedance, the internal resistance increases, and that causes there to be heat buildup in the capacitor. And bulging comes from gases created inside the cap after it's heated up, and it only heats up after it's turned high impedance. So you cannot have a bulging capacitor without a high impedance being there before. Unless you've pole swapped it or something, installed it the wrong way around. But if you're replacing caps in a working unit, any bulging cap will be bad, but not every bad cap will be bulging. But this is really an oddity. I didn't like the look of it, so we're going to replace it anyway, just to be sure. And let's compare it to our brand new Nichicon PS. So that one was 100 milliohms, and this is considerably higher impedance. This is 650 milliohms. Is there some really, really low impedance series? The PS series is pretty good. Is this really 100 milliohms? That's weird. That is weird. 100 milliohms. I need to check the datasheet for Capxon KF series to make sure that Nichicon PS is going to be a suitable replacement. Capxon, what was that? KF PDF. Low impedance. 2,000 to 5,000 hours. So this is going to be a decent capacitor actually, as long as it lives up to its spec. Do we have impedance ratings for these? It's going to be 50 volts, 100 mic. That's actually specified for a maximum impedance of 170 milliohms. with about 500 milliamps ripple current. I need to really check that an Nichicon PS can do that. Because if it can't, then we're basically screwed. Maybe the PS isn't all that good actually. Let's see. So there's the height. That's going to be 100 microfarad, 50 volts, rated 400 milliamps and maximum 360 milliamps. Oh no, it's just rated 340 milliamps. No, 340 milliamps ripple. So this capacitor actually has a considerably inferior rating to this crappy Capxon. However, I wonder if that's just a question of Capxon overrating their components. But perhaps we need to take some precautions anyway. Perhaps we can put 2 in there, or if I have a 220 50 or something of that order. I don't. Do we have another 150 to put in there? We do, but I don't have lots of them, so I'd rather not waste. You know what? We'll just put this Nichicon in there. I think it's going to be good enough. These bootstrap caps don't usually require super high ratings. They need to be low ESI. You can't just show like an 85-degree cap in there. That's not going to last very long. But the Nichicon PS series are low ESR, so it's going to be good enough, I think. But before we get to that one, we actually want to desolder the small one right next to it by the chip there, because it's behind the first cap. So that's the 50 volt 10 microfarads. It's right beside it towards the heatsink. So let's just flip over and find it. So that's the cap we desoldered, and is it? Oh, that's, yeah, I think it's those 2 pins right there. Or no, it's those 2 pins most probably. Those 2 pins. Do we have polarity marking on the boards? And negative side in the same direction as the big cap. So I'll just memorize that, and we'll desolder it and replace that. I'm holding my finger on the cap as the solder melts, because then I can feel the movement from my soldering iron moving the cap. That way I know I'm desoldering the right component. And there's no risk of desoldering the wrong thing and having it plop off the board somewhere for you never to find it again. And there's our little 10 microfarads 50 volt. Let's just measure that for the sake of it. It's probably fine. I think most caps in this thing are fine. 10 microfarads, 2 ohms. Comparing it to our replacement, we get basically the same thing, except this is a much higher quality Nichicon PW cap. So this is actually a low ESR cap we're replacing it with. That's good. Well, it's obviously a low ESR cap because the ESR of non-low ESR caps generally are for 10 microfarad. You can see about 10 ohms, and lower than that you have a decently rated low ESR component. We'll just snip the leads on that, poke it in, making sure it goes the right way around. Now remember, these markings on the board can sometimes be wrong, so I'm going by the mental note I made rather than the marking itself. The marking is just there to serve as a helpful reminder. But always when you're doing this, make sure you make a mental note of which way the cap goes. Now that's gone horribly wrong. Now focus has gone horribly wrong. Everything's gone horribly wrong. Stop focusing on whatever you're focusing on. Jeez. Where are my tweezers? I think the lead spacing is slightly off, so I'll just widen the legs and give it another go. It's important to spread the legs right. There we go. If you don't spread the legs right, it's not going to go in right. And once it's in, you spread the legs even wider. That way it won't come out again. There we go. I've also got myself a monitor arm here so I can actually see what I'm doing on camera, which is very, very helpful. In fact, I can even be smart a bit and bring this thing down a bit, I think. Yes, oh, bollocks, I turned the monitor off. This has gone horribly wrong. We are being professionals. Wow, I can't see shit now. And I turned the monitor. Okay, we're not doing that because it's gone so wrong. I keep turning the monitor off because the buttons are on the side. It doesn't matter, this place is getting scrapped rather soon anyway. So let's just solder that in place and be on our way. I don't think I will need to do much else to this unit. It seems to be in decent health. Otherwise, the secondary side caps could do with getting swapped, but I don't think this thing has crazy hours on it, and I don't have any suitable replacements anyway. Why are we out of focus? There we go. So, snippety, snippety, snap. I want to rhyme something to trap, but that's sexist. Snip. There we go. So that's 3 caps replaced out of a total of a lot, but I don't think we need to really replace any more of them. The rest of them are probably in decent shape. Secondary side cap failure is actually relatively rare on decent quality modern power supplies, although often out of all the caps which fail, universally this one seems to be worst off. In most designs it seems this is the 5V standby cap. Like, let's just see if I can find another power supply for you to see that it's got that cap in pretty much the same place. Yep. So this is a completely different power supply from a different manufacturer. So if we put the boards right next to each other, they're going to have a similar layout, and this one's supposed to have a rectifier heatsink here, but it's removed. But we have the same capacitor there. This cap and that cap, they're almost always there, and it's the one that fails. Most commonly, 5V standby cap. Often that's also the only failure, so this is probably a 10V 2200 mic. Perhaps we ought to replace that. That's a 16V 2200. Well, bollocks. Well, in that case, maybe it'll work. Yeah. Yeah, it's a 16V, so it's going to be fine. Let's just put this thing back together and see if it works. Or if we've ruined it. Just the other week I actually managed to install a whole bunch of capacitors the wrong way around in a really expensive JBL speaker. That wasn't a particularly good day. There wasn't smoke though, because I always monitor devices on the power meter as I plug them in after a cap change, because anyone can put a cap in the wrong way around. It does happen. So I just saw in that particular case that the speaker, which was supposed to be drawing about 30V in standby, was drawing about 200V in standby. So I turned it off in roughly 2 seconds. The caps ran very hot, but it didn't either explode a rectifier nor let the smoke out, so it could have gone considerably worse. But in this case though, I'm quite confident we haven't messed it up that bad. I think we're good. Let's see what the chat's got to say for a sec. Fluffy Floofy says, it vibrates and sucks simultaneously, and it's very hot. Heart emoji. And Fluffy Floofy says, you don't announce your live streaming on Twitter? I don't really use Twitter, I just do the default like YouTube automatic tweets, so if it doesn't automatically tweet it for me, then I don't know. Someone's asking NDA about the ESR meter, and no, it's more of a friend who's built it. He doesn't want it released, and well, he's a friend, so I'm going to respect his wishes. Conjure asks, what about SUSCON? The FP cap apparently were used by some manufacturers in the high-end version. I've seen some good SUSCON, I've seen some bad SUSCON. There are some of them which certainly last a good long while. Okay, let's just give this thing a quick test. I'll just dig up some trashy PC motherboard and we'll see if it powers on. What do we have? Oh man, do I even have anything? Oh yeah, I've got a Pentium 4. I've got a Pentium 4. It doesn't have any RAM, but I think this board actually works, despite it being horribly abused. So let's just see if it works. The sharp eye, the eagle eye among you might also be noticing that this is one of those weird early LGA 775 boards which came with DDR1 and DDR2 slots. So this thing can take either DDR1 or DDR2. Very good for legacy. Power everywhere. We don't need a heatsink. Let's plug in a fan though so we can see that it's actually turning on. This one's got blue LEDs, so it's nice and visual. Where's my power? There's my power. And you're not going to see the power meter, but I kind of am. So, is this on? No, it's on. We don't have ground connected, but that's fine. So, let's just turn the power on, see if it's gonna explode. I didn't even bolt the PCB in. So it's drawing 1 watt in standby. Doing nothing, so I don't think it's gonna go on fire. Let's just poke this. Is this board dead? Reset. Power switch. It's turning on, drawing 70 watts. Our Pentium 4 is doing its thing. About to go on fire. I think this is going to be good. I think this is going to be good. Excellent. Good result. Good results. So let's just mount this thing back. In fact, let's plug in the fan first to see if it needs to be replaced. I should have a few spare 120mm fans lying around of varying quality. In fact, let's bolt the PCB down so I don't forget. It would be a bit annoying to have 230 volts in all the wrong places. Someone says P4 Rocks had one at 5 GHz. You poor sod. The highest I ever got my Pentium 4 630 back in the day was like 4.7, but that was on terrible air cooling. It did work though. All glory to the Prescott core. This screw is full of garbage. Probe time. There we go. Let's do the most horrible one first. It's going to be that one. The shooting screws right across the bench there. Fluffy Floofer says, we've got fan spin. Sadly though, unlike Rossman, we didn't make $400 out of it, but perhaps we made... What's this paste going to be worth? $30 maybe? Something like that. It's a decent revenue for my poor ass anyway. And someone gave me $5. That can turn the €995 internet bill into a €990 internet bill, almost. In you go. Stupid thing. God. This is impossible. This screw is a dick. Let's use another one. And this board is a dick. There we go. Someone says, would love to own a Willamette board though. Rambus and a very weird socket they only used for less than a year. Willamette was garbage. To those who are not in the know about all the Pentium 4 cores, Willamette was the code name for the very first Pentium 4. It was terrible. It ran hot, it was slower than a Pentium 3, and really expensive. And used horrible proprietary memory in the older revisions. Yuck. Yuck. I used to run a Willamette PC once. Never ever again. It was the worst experience you could possibly even think about. It's like a Pentium 3 except everything runs slower. I'm going to replace it with a like Pentium 3 1 GHz box and I was happy about it. There we go. Alphonse Jean says, someone would pay €30 for this? Yeah, I think you could sell a Corsair branded power supply for 30. Keep in mind I live like on an island where importing things is really difficult, so there's a huge markup on everything. And a new power supply like this would be probably no less than €80. Definitely no less than €80. Bolting them connectors in. I'm actually very happy about fixing this thing because I have a bunch of leftover modular cables from a HX520 I used to own, which broke. And they just wanted a power supply back on warranty. I got to keep the cables and they fit. I think the pinouts are right. Let's plug in the fan and see if it's any good. I think this fan is going to be garbage. So I want to run it in that orientation since that's the worst orientation for sleeve bearing fans. And I'm going to need myself a power on jumper, which I think I have stuck in a test power supply somewhere. Nope. Where is my power on jumper? It's supposed to be in this box, which means it's never in this box. It must have escaped in some power supply somewhere around the workshop, but I can't spot it in the corner of my eye, which is annoying because it's something I'd rather keep around. But I guess we're out of luck. We are out of luck. So, piece of green wire to the rescue. Green goes there, black goes there. So when we turn the power on, this should now spin. It does. How's this sound? Slightly rattly, but not as bad as I thought. I was expecting a lot worse than this. That's surprising. This could actually be okay. I'm very surprised sleeve bearing gate loon fans tend to shut up, you stupid soldering iron. These gate loon fans, yeah, they never tend to last, so this thing must really not have that many hours on it. They must not have this must not have many hours on it. Should we replace it anyway? Do I have anything better? I don't think so. Let's just run it till it dies. Let's just run it till it dies. And we'll put the cable ring back on, like so. Poke the wires where they're supposed to go. Completely disregard putting the zip tie in place because I don't quite care. These are stable enough. Yeah. And on goes the case. There we go. 4 screws and we're done. 4 screws, and I think this is going to run forever. It's the best power supply ever made. It better be worth it. What's how we put... I've been working about an hour on this, so yeah, not doing a very good hourly wage getting this thing up and running. But there are worse ways to spend your time. Arman Cordis says, I love your UPS/Soglass/battery videos. Yeah, glad to hear it. There should be something coming up relatively soon if I ever have time to finish it. So, should we load test this in any more proper manner? I don't think it's justified. I think this power supply is just gonna work fine forever, because I don't think this has ever had any issue. Save for the fact that someone forgot to take off the protective plastic thing, so I'm gonna do that right now. It's no longer a virgin. Protective plastic thingy comes off. beautiful. Absolutely gorgeous. And that, I think, is done. 3 caps replaced. I think this thing worked fine before. It's probably going to work slightly better from now on. I have put an hour of my life into it, so it's going to go in service in some PC somewhere. So what's the chat say? I'm gonna read that, then I'm going to sign off. Someone says this repair was way too easy. There's no such thing as a repair that's too easy. Someone says, oh no, did you just turn a Corsair PSU into a PC PSU? I have no idea what you're talking about, man. Jorg Zabo says, hi FF, hello, you're way too late, I'm sorry. Now build a rocket. Someone says, with the new Corsair logo, so it can't be so old. It's dated 2014, so it's 4 years old. Jorg Zabo says, what do you think about e-waste? This is e-waste. Well, it was e-waste. But yeah, that's gonna be it for the time being. This thing is fixed. And charge the battery pack. My power bank's died. Okay, fair enough. That probably means I'm gonna run out of audio in a matter of seconds, so goodbye.